better measurements of the V here. So we will see how that looks. Jump off the top here, and here we see the temperature 1 point, so it's 180 degrees Celsius. I have the temperature sensor here on the top. Hopefully it cooled down a bit so it's slow. And then I have changed this messy setup. I hope I this is a bit tricky. And then you see there. Okay, I have disassembled the messy setup, and the last test I crank up the temperature to around 190 Celsius. I have some 3 and 2 candles with heavy duty flames, as you see, and a temperature sensor on the top under this glass foam isolation, and some silicone attached. So at least I know that the top here was approximately 190. I know they have fall off some aluminium plates, but what I'm really curious about is if the foam glass have cracked because the temperature near 200 Celsius. If that's the case, then I will probably not continue with the idea of using foam glass as a displacer. If it holds, then I will continue. So we will see what's happened when I open. Now, my friend, I am excited because I will try to disassemble this. I haven't opened it yet, so I'm as curious as you are on this. How will it look inside? It was a bit tricky to remove all the silicone. I think, alright, let's see. Alright, I know that there was some of these isothermalizer plates who was fall off, and here, because it was not so great done. But now the interesting situation is when we look at if there is some cracks on the glass foam. Yet I couldn't see anything. So it looks like I should continue with this ID. So 190 degrees was not any problem. I couldn't see any cracks whatsoever, because I was a bit worried if it splash up water and it's, you know, the knocking effect and so on. It looks quite great, because if it was cracking, then it not only cracking itself, but also in the crack it will add on dead volume, because when you have and that's really annoying. I do not want to add uncontrollable dead space. Anyway, use aluminium at top. I would not recommend that if running very high temperature, because it maybe are some there could maybe be some sort of dangerous dangerous situation, maybe if you put on enormous amount of heat, so you go above the melting point of the aluminium. Maybe it could melt and drop down in the water, and then you maybe have a dangerous situation, because the melted aluminium will have a phase shift down to a solid material and release a huge amount of energy in that case when it dropped down in water, and maybe produce a lot of steam, and that could be dangerous. So I encourage you to give me some advice. If you, for instance, I have think about the steam hammer effect, but that's not seems to be an issue. But in another case, some sort of steam if something goes wrong. Actually, the large one I will do so the bolts here will have plates on it. So if you go above, let's say, 1.5 bar pressure, then the whole vessel should separate and release its overpressure to not explode if some strange event happens. But anyway, this looks promising so far. I could not see any cracks. That's what. Another thing is I want to put holes in here and test that, and put a lid here and force the air to go through the glass foam as a regenerator. Also, the knocking effect I have thinking about to add on some sort of hydraulic damper just before the displacer hit this top. It should have another little bit larger pipe with an so the water have to squeeze just the last millimeter before it hit the top. Then it could be controlled. All right. Next thing will be a water turbine, small water turbine. I will add on this. I will made a better isothermalizer package, I guess, and then test that idea in this small one before I continue with the large one. To strip out some data from the first 140 samples from the, and I clearly got two lines here. Actually, this is a great pressure volume diagram. It was a bit tricky because when I changed the temperature I was filling in more water, so I have to strip out a small amount of data. So this is maybe a few cycles, 150 samples. Actually, this may be one cycle approximately. There is some bouncing effect here in the red, and that's is things happen in this region because we have the check valves. So we have a peak up there, and there's a lot of things we don't really understand. Anyway, there is two lines, and this was what I expected. This was at around 170 degrees on the top of the displacer, but the mean temperature I don't know. Maybe it's probably lower. I expect that 150 or so. Maybe it is, and I this area is actually the power, the energy, the energy from one cycle. So it's about the energy from one cycle is about this area, and it's about 5 joules. So if it's 0.5 hertz, when it's 2.5 watts of power. So that was tricky because I have some other images when I clearly see that there was several this was yesterday, it was completely garbage because wrong sensors. Then I have here, we see clearly I fill up water and change the volume measure. So this is one pressure volume diagram, and here we see another. So it was a bit tricky, and here we have the bouncing effect at the top. So it's clearly quite bad but test. But anyway, it seems like I mean, at least one part here looks quite convenient. So, and it will be nice when the water turbine is attached, because then actually we can use the water turbine as a volume, relative volume sensor also. Right. My rabbit, my little also want to talk with me. I write very rough sketch of maybe thoughts of 3D printing plastic. Very good friend of mine have skills with 3D CAD and also have some 3D printer. Another very good friend have also say he could help me with some materials for some steel for the big engine, 2 and 3 millimeter plates. So it's nice to have friends who follow my crazy project. Anyway, this will be maybe for the small one, is instead of a long charging pipe and check valves. So this will replace that, and also it will make it both a principal test for the extraction of the power, but also you could use the turbine itself for a volume sensor, relative volume sensor, for the pressure volume diagram, just for evaluation. And then we have the theoretical isothermal output power calculation of this integral calculation, but we can take that another day. I have put this calculation on my GitHub also.